Now, in the previous video, we discussed the concept of a confidence interval. We said it's a very useful tool to indicate what is the range in which the different sample means are located. So it shows us the sampling error in a way. And it also tells us a little bit about the population mean, the unique population mean, which by default we will never know, but it gives us a good idea in which range the population mean is. And we said it depends, the confidence interval, the size of the confidence interval depends on the variability within the population. Now that's something we really don't have a lot of influence. We can't change this variability. It depends on the sample size. The larger the sample size, the smaller is the confidence interval, and that is something we have control over. So instead of 9 observations in my sample, I can increase the sample size to say 90 to 900, 9,000 or so if I've got the resources, but I've got control over that. And the last bit is what is called the error that we are willing to accept. And again, that is something we have total control over. But what is this error? What am I talking about? Okay, first of all, let's say we make this confidence interval fairly small. We make it really small, just simply on the basis of just a few samples or something like that. We say we want to have a really small confidence interval. And this is indicated here with this blue line. So that's my confidence interval. We would call this here the lower bound. Lower, and this is the upper bound of the confidence interval. And as you can see, it's fairly small. And what we also see is that there are some samples, some sample means that are not included in this confidence interval. So I might find a sample. Let's say I find this sample here. And I say, right, I've got this value for a sample. So for example, we might have sample 7. And this is, say, 3.2. And if I've got my confidence interval, which goes from, let's say, 4.3 to 4.8, I would say 3.2, that is not included in this confidence interval. And remember, the confidence interval includes the samples that come from the same population. So I would say this 3.2 sample here, this sample here, does actually not belong to the population, not sampled from the population. Not sampled from population. But in fact, it is sampled from the population because it's just a sort of a freak occurrence that I've got this very small sample mean. So I would make an error here by excluding this sample. It does belong to it. It's just my confidence interval is too small. And this is actually called an type 1 error. Type 1 error. I exclude the sample, although it's part of the population. This is very often abbreviated with an alpha sign. So that's a type 1 error. And obviously you can guess there will also be a type 2 error. And that is, the type 2 error is when we make the confidence interval too large. So type 1 error is confidence interval too small. Type 2 error is if the confidence interval is too big. So what will happen? Well, you see here with these different colors, my my population that I'm interested in is this black one here, as before. So that's my non-diabetic people. And if I make the confidence interval too large, then I might get sort of interlopers. I might get samples from other populations. So here, this is a different population. This is here the non-diabetic. And these are here people with chronic low sugar. So low blood sugar level. And these are different populations. But by making the confidence interval too large, actually, I say, yeah, I believe that this person who comes, or this sample who comes from a different population actually is included. So I include, in this case, I include samples that do not belong to the population. And this is called a type 2 error. So type 2 error. And it is usually abbreviated with the Greek letter beta. So we've got type 1 error, that's alpha. That is when we do not include samples that belong to the sample. And type 2 error, that is when we include samples that do not belong to the population. Now, ideally, what we want is we really want to find the sweet spot, and very often we are not too worried about the type 2 error. We are more worried about the type 1 error, and what we do is we try to estimate. So we try to estimate our confidence interval. So estimate the confidence interval so that the alpha, the type 1 error, is relatively small. And very often you will find it that this alpha is set to, say, 5%. That means if we have 5%, then 5% of our samples, we accept that they are outside this confidence interval. So 5% for the error means 5 out of 100 samples are outside this confidence interval that we estimate. Or in other words, 95% of the samples are within the confidence interval. And that would be called then a 95% confidence interval. We don't have to set it to 5%. We can set it to, say, 10%. Well, if it was 10%, then the interval, the confidence interval would be smaller. So it would be perhaps somewhere between here and here, would be slightly smaller, because then 10% of the samples would be outside for when we set an alpha to that level. We can set it to, let's say, we can set alpha to 1%. Very often it's done like that. That then would mean that the confidence interval gets larger because we need to capture need to capture more samples because we only want 1% of the samples outside. So in this case, the confidence interval would go up. And depending on our decision, what we want this alpha to be, how many of the samples we want to be within this confidence interval, that is something that is in our control, and that will actually contribute to the length of this confidence interval. So I hope this makes sense, and thank you very much for watching.